All right, in this exercise, we're going to use a ratio test to determine the radiance of conversions for this series. Doing one from the next group. So here they tell us to use the ratio test. We've been using the ratio test for the others, but here they give us specific instructions to do so. So let's take the limit as n approaches infinity, the absolute value of what we have, n plus 1. So we have n plus 1 factorial quantity cubed, and then we're going to have that over 3n plus 1, 3 times n plus 1 factorial, and then we're going to have x to the n plus 1. I guess we can just put that on top. All right, because that's out here. Let me highlight that. That's in the numerator. It's they've got it multiplied by it, but really that goes in the numerator for now. And then we're going to divide this by exactly what we have. N factorial cubed x to the n over 3n factorial. We do the same thing. We multiply by the reciprocal. N plus 1. Yeah, so I've got a notation problem here. Let's do this, that, and then that. It's got to be in the outside there, like I have down here. So I can distribute this here. So this becomes 3n plus 3 factorial. And we're multiplying here by 3n factorial over n factorial cubed, and then x to the n. All right, so the easy ones, the x's go away. Oh, and this should be cubed, excuse me. The x's go away, that's not a big deal. Let's see what we can clean up. Okay, so what we have up top, so n plus 1 cubed, n plus 1 factorial cubed over n factorial cubed. Well, that's going to give us n plus 1 cubed, because that other bit all goes away in the same fashion. So essentially what we have here, n plus 1 factorial over n factorial, all cubed, right? And we know that this is equal to n plus 1 cubed. So that's where I get that first bit. All right, the next piece. Well, we have an x, so let's add the x here. What do we have left? So let's write kind of what we have here. So we have 3n quantity factorial, and then on the bottom we have 3n plus 3 quantity factorial. That's what we're going to need to kind of break apart. The other bits worked okay. All right, so we have this n plus 1 cubed times x. And then on the bottom, we have this 3n plus 3. And then we have 3n plus 2. And then 3n plus 1. And then 3n factorial. So now we can cancel these two guys out. And then on top we have n plus 1 cubed. And x. And then on the bottom we have 3n plus 3, 3n plus 2, and then 3n plus 1. All right, so how do we do this? Well, we're going to get a cubic n on top and a cubic n on the bottom. So we're looking for essentially the leading coefficients. I can FOIL out the n plus 1 cubed the whole way. I don't need to do that though. We know that the squared and the x and the other ones don't matter. So this is going to be equal to limit as n approaches infinity. This is going to be n cubed. They're all a 1 in front of them plus a bunch of stuff. That's going to be lower than n cubed. And on the bottom, we've got 3 times 3 cubed essentially. That's going to be 27. So this is going to be 27n cubed plus whatever n squared and so forth. So this is what we have. And when we take the limit of this, we've got a cubic over a cubic, which means that as we pull all these out, we're going to be left with the values there. So that's going to be 1 over 27. So the limit of this is going to be x over 27. Now, we need to know, so by ratio, test, this has to be less than 1 to converge. To converge, that's what we need. And then that means we get absolute value of x is less than 27, and that is what our r is. So our radius of convergence is going to be 27 for this.